Good morning, ladies and gentlemen. Okay, so today, ladies and gentlemen, we are going to be reviewing and going over the area and circumference of a circle and therefore a sector of a circle. So, as you see in front of me, these are going to be the key formula we're going to need to know for this section. So, for the length of a circumference of the circle, so if you just remember, if I have a circle here, the circumference of a circle is the perimeter of the circle, so it's all the outside of the circle. So how do we calculate this curved length? I can't just take a ruler like this and start measuring bits and bobs and bits. You know what I mean? I can't be like, that's 1 centimeter, 1 centimeter, 1 centimeter. That's impractical, ladies and gentlemen. Right? So how can I calculate the circumference of a circle? Well, there's a very special number, ladies and gentlemen. So it's a special number. It's called pi. Maybe you heard of it. Looks like this. So pi is a very special number because as it represents the ratio between the diameter of the circle. So this is the diameter of a circle. So the diameter of a circle is just a line that passes through the center that connects 2 points of a circle. So this is called the diameter. And half of the diameter is called the radius. So the big black line, diameter. Then the green line here is my radius. So pi represents a special ratio between them. And this ratio is the same for every circle, no matter how big, no matter how small. So as I said here, the diameter, or sorry, the circumference of a circle is 2 pi or pi times d, where or is the radius and d is the diameter. But how did we come to this, and what is pi? Like, what is pi equal to, right? So we're going to look at a proof now on GeoGebra, my favorite. So let's go over there now. So here is a circle. Let me make myself a little bit bigger here. So here is a circle. This circle is a diameter of 2 and it's a radius 1. So this is also known as a unit circle, okay? So what I'm going to do now is I'm going to unfold this circumference here. So I'm going to unfold this circumference. There it is. I'm unfolding it out. And there's the length of it. So I have the length of the circumference is equal to 6.28, right? Okay, whoop-de-doo, what's it mean? But now let's notice the relationship here now between the diameter and the circumference of the circle. So let's see how many times I can fit the diameter within my circle here. So I can fit it once, twice, 3 times, and then looky here. Look at this bit. So it fits in 3 and a bit times. But what's this little bit here, right? So that is going to be the irrational part of pi. So if I go back now here to my main page. So we could see pi is going to be equal to the circumference divided by the diameter. And if we saw there, it went in 3 times and a little bit. That little bit is 1.14159, blah, 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 blah. It goes on forever and ever and ever and ever and ever. It's called a irrational number because we cannot express it as a fraction, right? So pi is just a special relationship between circumference and diameter. It's the same for any circle. If you get any circle and then see how many times you could fit the diameter around the circle, you're going to get 3 and a little bit, and that is going to be pi. So in your Leaving Certain Junior course, you are going to be asked to use certain approximations of pi to calculate answers for things. So that is going to be, you're going to use pi as pi on your calculator, or you're going to use pi as 3.14. Or you're going to use pi as my least favorite one. It's so stupid. I hate it so much. Anyway, 22 over 7. Right? Because 22 over 7 gives a rough approximation of pi. Even though we said pi can't be written as a fraction, I didn't make the rules. Anyway. So let's have a look at our first question here. So find the length of the circumference of the circle using 3.142 as an approximation for pi. So I know the circumference is equal to, so if you look up here, top of me here, this is what you're going to get in your formula and table book. So you see on the left image here, I have L is equal to 2 pi r. So L just means the length around the circle or the circumference. So the circumference is equal to 2 pi r. Well, my radius is going to be equal to 12 from the circle here. Pi, we are using the approximation 3.142. And then the 2's is going to stay the same. So circumference is going to equal to 2 times 3.142 times 12. And that is going to be a number that's kind of big. And I'm going to do it up right now. So 2 times 3.142 times 12. 75.408 centimeters. So that is what my circumference of the circle is. So if I was to snip the circle and lay it all out flat, I should get a circumference of 75.408 centimeters. So that is the formula of the circumference of a circle. Now let's look at the area of a circle. Right, so the area of a circle is given by the formula pi r squared, where r again is the radius of my circle, so i.e. half the distance is a point from the center to any outside point on my circle. So the area is equal to pi r squared. Okay, well, where did I get that from? Again, let's go back to GeoGebra and see a visualized proof for this. So if we look here, here is a sakal that is cut into 8 slices. So what I'm going to do is I'm going to unfold this circle. So I cut the circle into 8 slices. I'm going to unfold this circle here. And now what I'm going to do with these slices, I'm going to put them on top of each other like this. Now I'm left with a parallelogram. Right, and remember the formula for the area of a parallelogram is base by perpendicular height. So we have a rough parallelogram here. So like my base is roughly going to be pi or half the circumference, right? And my height is going to be the radius. Well, that makes sense because if this is my center point and this is an end point on a circle, this is going to be my radius here. So it's kind of like a parallelogram. So let's now... what happens if I increase the slices I did on my pizza? So let's increase it now to this many slices. If I unfold my circle now, so the length of it here is still going to be half the circumference. And then if I move the pieces together here, the height is still roughly going to be radius. So let's increase the slices even more. What if I had infinitely many slices of this circle? So you might notice the more and more slices I add to this circle and put them on top of each other, I'm getting closer and closer to the area of a rectangle, aren't I? So if I had if I had a lot of slices and I put them on top of it, I'm going to get closer and closer to the area of a rectangle. And how do we get the area of a rectangle? Well, it's just base times height. So if my base here, or length by width, I should say, length by width, well, if the length of my rectangle is going to be half the circumference, which is pi r, and my height, or my width is going to be my radius, well, pi r times r, well, that is going to give me pi r squared. Right? So that is how we get the area of a circle, ladies and gentlemen. So let's do a question here. So find the area of a circle, radius 14 centimeters, take pi to be 22/7. So find the area of the radius of 14 centimeters, take pi to equal 22/7. So the area is equal to pi times r squared. Well, we're taking pi to be 22/7. And we're taking my radius to be 14. So that's going to be 22/7 times 14 squared. So we'll put that in a calculator. And we're going to get 616 centimeters squared. So that's going to be the area of my first circle here. The next question here asks us, find the radius of a circle of an area 1,386 centimeters squared using the pi key on your calculator, and give your answer correct to the nearest whole number. So we're going to need to use a pi key on our calculator here, because our calculator will have pi to a lot of decimals, so giving us a better accurate answer. So if I have the radius here, so I have the area is equal to 1,386. And I know the area of a circle is equal to pi r squared. And asked us to find what the radius is. Well, I have a pi times the radius here. So I'm going to divide both sides by pi. That's going to equal r squared. Then I want to undo the squaring on the r. So I'm going to square root both sides. So I'm going to have r is equal to square root 1,386 all over pi. So now if I put that into my calculator, uno momento, por favor. So, oopsies. There's my calculator here. So, what I'm going to do is so the square root of 1,386 all over pi. Put in my calculator, click equals 21.004, or we're just going to roughly estimate it to the radius is equal to 21 centimeters. Right, so that's my rough estimation of pi there for the area. So now that we know how to calculate the circumference in the area of a circle, what about a section of a circle, right? So I have the length of an arc. So if I have a section of a circle and I'm being asked to calculate the curved part, right, that's called the arc. And what we do there is we're basically finding a fraction of a circle. So if I have a circle here, and this segment is theta amount of degrees, so this is the Greek symbol for theta. If I had like x amount of degrees here, how I find the length of the arc is, well, I find what fraction of the circle I'm dealing with. Well, if this was like, say, equal to 60, I'm dealing with 60 over 360, or 1/6 of a circle, yeah? And then I multiply that by the circumference, and that'll give me the length of the curvy bit. Same as here with the area of a sector. Well, if I want to find the area of this sector, well, I just find A, where what fraction of the circle this is, and I find what fraction of the circle it is by putting what degree the circle is and put it all over 360. That'll give me what fraction of the circle it is, of a whole circle it is, and then it's multiplied by the area formula, which is pi r squared, and that should give me the area of a sector. So let's do a question on that now. So, the diagram on the right shows the sector of a circle of a radius 21 centimeters. Find the length of the perimeter of this figure. Use 22/7 as an approximation for pi. So, I have pi is going to be equal to 22/7. My radius from this question is going to be 21 centimeters. The degree I'm working with, or the theta I'm working with, is 60 degrees. So let's have a look at the circle. So what fraction of a full circle does this slice represent? Well, if I put 60 degrees all over 360 degrees, yeah, that is going to be 1/6. So this represents 1/6 of a circle. So if I want to find the length of the curved part here, right, I need to do, so multiply that 1/6 by 2 pi r. So it'd be 1/6 times 2 times 22 over 7 times 21. And that is going to give me now 22 centimeters. So the curved bit here is going to be equal to 22 centimeters. But now the question asks, find the length of the perimeter of this shape. So we're looking for the perimeter of this figure. Well, so remember the perimeter is the length on all the outsides. So remember, I have my curvy bit here, my arc, which is 22 centimeters, but I also have my radius here of 21 and my radius here of 21. So I have to remember both them parts. So then, therefore, my perimeter is going to be equal to 21 plus 21 plus 22, which is going to be equal to 64 centimeters. And that is the perimeter of that shape. If I wanted to calculate the area of this sector, now, again, it's going to be the degree it is over 360 multiplied by pi r squared. So the area is going to be 60 degrees over 360 times 22 over 7 times 21 squared. And if I put that in my calculator, I get 22 times 21, 21, 6. I'm going to get the area is going to be equal to 231 centimeters squared. So that is how we calculate the area and perimeter of a sector of a circle. And remember, these formula are in your log tables. Anyway, I hope this video was a bit of a help. So I'll catch you later, everybody. Bye.